Welcome to the Introduction to Machine Learning. Today we will be talking about decision trees. So what is a decision tree? A decision tree is a largely used non-parametric effective machine learning modeling technique for regression and classification problems. To find solutions, a decision tree makes sequential hierarchical decision about the outcomes variable based on predictor data. A decision tree uses nodes and leaves. Leaf nodes are the nodes of the tree that have no additional nodes coming off them. They don't split the data any further. They simply give a classification for examples that end up in that node. Decision trees are built using the divide and conquer because it splits the data into subsets, which are then split repeatedly into even smaller subsets, and so on and so forth until the process stops when the algorithm determines the data within the subsets are sufficiently homogeneous or other stopping criterion has been met. Splitting is a process of dividing a node into two or more subnodes. The very idea of decision trees is that the splits at each node are rather simple and more complex structures are captured by chaining several simple decisions in a tree structure. A split is called univariate if it uses only a single variable, whereas a split is called multivariate if it uses all the variables. We can also use classification and regression decision trees to divide and conquer. Now we will be talking about classification trees. The classification trees are ID3, CART, and C4.5. For node M, NM, instances reach M, NM, I belong to Ci. Node M is pure if PMI is 0 or 1. Measure of impurity is entropy. Now we'll talk about best split. Best split is when we can separate the classes accurately based on that feature. If node M is pure, generate a leaf and stop. Otherwise, split and continue recursively. Impurity after NMJ of NM take branch J, NMJI belong to Ci. Find the variable and split minimum impurity among all the variables and split positions for numeric variables. So in this slide, you're seeing the algorithm to generate a tree using split. A regression tree refers to an algorithm where the target variable is and the algorithm is used to predict its value. You see in the slide you see error at node M and after splitting. This slide shows us the examples of model selection in trees. By pruning, we mean that lower ends, that is the leaves, of the tree are snipped until the tree is much smaller. Remove subtrees for better generalization, that is decrease the variance. Pre-pruning is early stopping. Post-pruning is grow the whole tree, then prune subtrees which overfit on the pruning set. Pre-pruning is faster, post-pruning is more accurate, and it requires a separate pruning set. This is the example of rule extraction from trees. Rule induction is similar to tree induction, but tree induction is breadth first. Rule induction is depth first, one rule at a time. Rule set contains rules. Rules are conjunctions of terms. Rule covers an example if all terms of the rule evaluate to true for the example. Sequential covering. It generates the rules one at a time until all positive examples are covered. This is the algorithm to generate rule set. This slide also shows us the algorithm to generate the rule set. Multivariate trees. Multivariate trees are decision trees that use multiple variables. A multivariate decision tree is not restricted to splits of the instance space that are orthogonal to the feature's axis.